Welcome to today's video. Today we're going to be focusing on simplifying expressions using the law of exponents. And this time we're going to focus on quotients to a power. Again, we want to show that mastery in class by scoring at least an 80% on an exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a fresh sheet of paper. That way when you come to class tomorrow, we can give you a brand new set of notes. Now, when we talk about quotients to a power, a quotient is a division problem. So this is taking a division problem and raising it to a power. Now, we are still going to use some of the laws from the past two videos. So we want to make sure we're still following those laws correctly. Now, if we look at the first problem, the big thing you want to do, and my suggestion to you, is solve the inside of the quotient first, then raise it to the power. Well, if I solve this first, I can't simplify 5 to the 6, so I'm going to leave that there. However, 3 to the negative 3, I can bring that to the numerator because a negative exponent brings it to the top. Well, now I can use my power to a power, and I'm going to multiply both of those. I'm going to be left with 5 to the 12th times 3 to the 6th. Make sure you use it for all the exponents, not just one. You need to do it for all of them. Our second example, 2 to the negative 4. Well, 2 to the negative 4, I'm going to now bring that to the bottom, get rid of that negative exponent, and I'm going to leave 3 squared in the bottom since it's already positive, and I'm going to cube it. Now, for something like this, we want to take this 3 and we want to bring it to my top, and we also want to bring it to my bottom. Well, 1 cubed is still just 1, and now on the bottom I have 2 to the 12th times 3 to the 6th. Again, make sure you're distributing that power to all your different parts. Now, if we look at something like the third one, we have y to the 4th over y to the 2nd. Well, I know in a division problem I need to subtract my exponents, so this is going to become y squared to the negative 3. Well, y squared to the negative 3 is the same thing as y to the negative 6. However, we don't want negative exponents. So I'm going to turn this into 1 over y to the positive 6. If you give the answer of y to the negative 6, it is technically incorrect. You need to make sure there are no negative exponents. If we look at our fourth example, again, we want to simplify the inside. B to the 3rd minus b to the 5th. Well, 3 minus negative 5 gives me b to the 8th to the negative 2nd. Well, if I use my power to a power, that gives me b to the negative 16, which is equivalent to 1 over b to the 16. Now, if we look at something like the fourth problem, there is a lot going on, but we just want to simplify the inside first. So I'm still going to have 8 on the top, c to the 4th. This is technically c to the 1st. Well, 4 minus 1 is c to the 3rd. D to the negative 2 minus 3 gives me d to the negative 5. And we're still going to keep my 3 in my denominator. That's all to the negative 2. Well, from here, I would distribute 8 to the negative 2, and then I get c to the negative 6 and d to the positive 10, and I still want 3 to the negative 2. Well, from here, I know I need to get rid of my negative exponents. I'm now going to have 8 squared in the bottom. I'm going to have c to the 6th in the bottom. Well, d to the 10th is already positive, so that stays up top. And 3 to the negative 2 is going to come to the top for 3 squared. So my final answer, well, we know 3 squared is 9, so it's going to become 9 d to the 10th over 8 squared is 64 c to the 6th. Because 9 over 64 can't be simplified, that's your final answer. Make sure, though, again, you want to get rid of those negative exponents. Let's look at the next one. Again, we want to simplify the inside. If we look, we really can't simplify much. So we're going to take it and we're going to distribute it. It becomes 9 to the negative 2, x to the positive 10 over 5 to the negative 2, y to the positive 12. Since both my exponents are positive, they're going to stay where they are. My coefficients are negative, so I'm going to flip it. It's going to become 5 squared x to the 10 over 9 squared y to the 12. Again, we didn't want to move the variables because they're already a positive exponent. Well, 5 squared gives us 25. X to the 10 stays the same. 9 squared gives me 81. Y to the 12th. Because 25 over 81 can't be simplified, that is your final answer. Hopefully you have a better understanding of quotients to a power. We will spend a lot more time in class on these tomorrow, both with positive exponents and negative exponents. Please make sure you bring your notes to class, and I look forward to seeing you then.